Good afternoon, everybody, and thanks for joining us today. My name is Brian Berryman. I'm a principal sales engineer here at EnterpriseDB, and I spend most of my time talking to customers about the merits of using open source software, and in particular, using our Postgres Plus advanced server product and the tools that we've developed to support it. I talk with customers every day who are moving from Unix to Linux, and I hear a lot of stories about why they're looking to make the same move from proprietary, expensive DBMSs to open source alternatives. There are many reasons to move to open source based solutions and to alternative database solutions. There's also a lot of things to think about as you go down this path. And of course, we believe Postgres can solve many of the issues and challenges that IT departments face, and that's what we'll talk about today. So let me begin by just saying that the intent of today's webcast isn't a sales pitch. It's not a commercial. Really, I just want to talk a bit about today's typical IT environment, and based on the feedback that we get from so many of our customers, to talk about what many companies are doing to address their challenges. I'll talk briefly about where we're seeing Postgres deployed, how companies are measuring success in order to, in a step-by-step way, continue to add flexibility, to reduce and avoid costs, and to develop for their future data needs. I'll try to provide some context regarding EDB and some examples of what we do for customers around the world, and to give you some comparisons between the open source versions and our enterprise version. And lastly, I'll make sure to leave a few minutes for any questions. So we've all heard the saying that the only constant is change, right? I'd suggest that that's true, but I'd also suggest that in some places that change may take place slower than we'd like. And the high cost of database services is one of the problems that we all face. Most companies are continuing to face cost reduction challenges. A decade ago, those challenges were related to the dot-com bubble burst. And now we've recently gone through likely the worst financial crisis we'll see in our lifetime. From an IT perspective, the fact that budgets are staying flat or growing slowly doesn't really jive with the expensive and ever-increasing costs of infrastructure software, the spend to keep things running, and all the complicated plumbing that's involved. Most companies spend almost 3/4 of their IT budget on just the plumbing. And in fact, database environments are often the most expensive part of the typical software budget. This means that we don't have enough money to spend on the future and on the projects that can help our companies grow. But why are databases so expensive? Basically, each database uses its own language. So when you're developing an application and you're writing it for a specific database, whether that's Oracle or SQL Server or whatever, your application is basically tied to that database. And that can make it very difficult to move, which in turn means that some database companies feel entitled to charge you a lot of money. I mean, let's face it, they know they have you locked in. But today we're seeing a major shift. Companies are realizing that they can't keep writing that big check for Oracle or SQL Server. It's really just not sustainable. So in order to effect real change, we need to do things differently. The move from expensive proprietary software to less expensive open source software is nothing new. Over the last decade, the move from Linux to Unix has become fairly commonplace. Linux gave us good enough technology at a fraction of the price of Unix, and it gave us confidence, knowing that there was and is a community intent on making rapid improvements in the technology, so that in no time, good enough technology became world-class, best performance technology. Commercial adoption fed the community's desire to succeed, and the community's ability to succeed fueled commercial adoption, so there's a real synergy there. We've seen a similar shift away from WebLogic and WebSphere to open source middleware solutions too. And now we're finally seeing the third leg of the infrastructure software stool move away from expensive and inflexible database vendors to open source based solutions, led by the adoption of Postgres. The DB Engines ranks database popularity using a number of different formulas. While we know that Postgres is one of the most deployed databases around the globe, it's included with virtually every Linux distribution in the world, and it's downloaded several million times a year. It's also popular in terms of searches, jobs requiring the database skill set, and other factors. What's more, Postgres was the second fastest growing database in 2013. Clear proof that enterprises are moving to the open source alternative. It's also fascinating that the other two databases in the top three were NoSQL databases, Mongo and Cassandra. More proof that companies are looking at new ways to get work done without spending a ton of money. What really strikes me with that DB Engine's data showing Postgres' popularity is the fact that it's become so popular now. Remember, the Postgres community has been around for a long time, since the 1980s. And in fact, the Postgres community is actually older than the Linux community. What our customers have been realizing over the last few years, though, is that Postgres has many of the same inherent characteristics of Oracle or DB2. Not many people realize this, but Postgres was actually created from the same technical white paper that Oracle used to create its first relational database. And Postgres has continued to evolve with the changing face of technology and an explosion of new use cases for databases. If you've been in this industry for a while, you know that every so often there's a new database technology that says it's going to replace the relational database. It's been that way for 20 years. But what actually happens, though, is the database vendors and projects take note of new technologies. They evaluate that technology, and if it's good, if it really resonates with what customers want, it gets incorporated into the relational database. We saw that with object relational features in the 90s. We saw it with XML features 10 years ago. These capabilities are now incorporated into most RDBMSs. And it's difficult to find many standalone companies that are servicing just object or XML demand. The same is true with NoSQL. The demand to do things differently drives new technology, and if that technology is sound, it will make its way into the relational database ecosphere. As an example, Postgres has incorporated many NoSQL features over the last few years. You may not be aware that with JSON, JavaScript object notation, you can use Postgres as a document-oriented database too. And HStore, which is Postgres' key value pair technology, that brings even more flexibility to the way that we can support new ways of storing and handling data. With foreign data wrappers, a data source from another database will simply look like any other table, which can be queried, it can be written to. And with a Postgres Plus connector for Hadoop, you can query your Hadoop data from Postgres Plus and write back to that same Hadoop repository. So in the end, we move where the customers and the technology takes us. In other words, market forces drive our evolution. So these are the main market forces that are shaping the future of PostgreSQL. On one end, you see the smaller applications, web apps, and app developers who need ease of use. They need rapid deployment. Over on the other end, you have large enterprise applications that need advanced features. They need security, they need scalability, they need high availability. These are really mission-critical applications. Postgres occupies a very broad middle ground position. And as I mentioned earlier, it's actually been gradually expanding in both directions. The emergence of new workloads and cloud will increasingly start to shape future customer needs and require relational database management systems to expand their range of capabilities. Gartner has actually also said as much. So these are the market segments that we continue to address to ensure positive future growth. Everyone would agree that it's important to be able to see where your technology is heading. Is it heading in the same direction you are? In fact, does the company or the project even know where they're headed? If you're going to invest in alternative ways to do business, it's critical to know that your partners have a vision, and it's equally important to know that they can implement that vision. You'll continue to see us expand to solve more workload issues in all three of these key areas. Over on the left, ease of use. diagnosing problems. People find this hard, and we're trying to make it easy. The out-of-the-box configuration, that should be more optimized for the common use case and less for niche edge cases. And are there ways that we can make that installation experience even easier? In the middle, big data and cloud, we're constantly looking to embrace new ways of handling non-traditional data and continually seeking opportunities to win the cloud. And over on the right, with the high-end enterprise requirements, we need to continue to work to take advantage of all the resources of a single machine. There's lots of machines out there with 256 processors now, much bigger than we've ever seen. Horizontal scaling, this is another big issue for the cloud and in general. You can figure out ways to do it if you're very smart. The challenge is to see if we can't lower the brain power required to do it. And diagnostics, of course, that's a request from every audience. So for NoSQL and for new SQL stuff, we're probably never going to reach all of their use cases. However, we should be positioned to integrate well with them. And our continued involvement and work on new data types is, of course, very important. So now let's take a look at how we implement, and we'll talk about workloads that are optimal. The expanded capabilities of Postgres that I just described means that we can deliver more value, both in what you can do with Postgres and in our ability to help you contain costs without sacrificing. Let's look at how these costs rise so quickly. Take an example. Let's say you might sign an enterprise license agreement. So you think that you don't have to worry about database costs for a few years, and that's great, right? But remember that an ELA is based on some target number of licenses. And what happens over the life of that ELA? Significantly more cores get deployed than you have licenses for in the ELA, which means at renewal time you might be in trouble. But what a lot of companies don't think about when they sign up for these agreements is the continual need to upgrade their hardware. And this usually results in servers that have significantly more cores than you had when you figured out what your target number was for the ELA. And when it comes time to reconcile, you discover that you owe them even more money, which means you probably didn't save nearly as much as you thought or you planned. And now maybe even your current budget is blown. Well, even if you don't plan on moving away from your current database provider, we can still help you curb your license creep and to stay within the guidelines of your ELA. With Postgres, you can create an environment that lets you take advantage of the right technology for the right workload and reduce your costs. We've actually even seen customers improve their leveraging power with other database vendors. So here's a question we get asked a lot. What should I do first? People ask us all the time. The simple answer is, it really depends. It depends on the skill set that you have in-house. It depends on what your plans are for cost reduction and application development. There's really a lot of factors here to think about. So in this one slide, really, we've tried to summarize a basic deployment strategy that we've developed with customer input. So here you'll see the strategy steps on the left, and on the right you see the associated benefits of that strategy. Now keep in mind that this isn't really a one-size-fits-all kind of a chart, but it's a good conservative approach that our customers have found successful, and we think it's a pretty good place to start the conversation. I mean, you remember back when you started migrating from Unix to Linux. How did that happen? You started with file and print servers, web servers, and then you moved to database servers and then deeper into the data center. You needed to gain comfort and confidence with Linux and with your team's ability to administer your servers. Well, the same is true and the same is logical, really, for databases. Databases just somehow feel trickier because it's where your company's valuable assets are housed. It's your data, after all. So while we do have customers that jump in with both feet, we typically see a more step-by-step progression of implementation, rolling out new database technologies in an easy place, such as new application development, rather than than in the migration. In a moment, we'll talk about some of the advancements in Postgres that really open up the new app development landscape. But for now, we'll just talk a little bit about replicating with Postgres, keeping your primary data in your legacy database if you choose, but replicating it for reporting and BI with Postgres Plus Advanced Server. And what this does really is it stops the purchasing of more and more expensive database licenses, and it gives you a way to get comfortable with Postgres and with what it can do for you. And from that standpoint, it becomes much easier to have a conversation about migration and application rewrites, which is where the biggest cost savings can usually be found. Oh, actually, before we go there, I don't want to spend a lot of time specifically on the cloud, but I do want to take just a minute or two to introduce the idea of database as a service. So cloud computing can be beneficial both from a cost savings perspective and from a flexibility perspective. Many of you may be moving or at least considering a move to cloud solutions for your IT. You pay only for what you use. You save costs on the reduction of physical environments, including energy costs. EnterpriseDB's Postgres Plus Cloud database is arguably the most flexible and easy-to-use database service that's available today. Not only can you set up a database cluster in a matter of minutes, but PPCD automates a lot of the administrative tasks so that developers can spend more time on their app and less time worrying about the database. And DBAs, well, they have virtually nothing to do unless they want to. And what I mean by that is that Postgres Plus Cloud database automates the scale-up, it automates adding storage, it automates failover, the backups, and all of these great things. And we give the super user the ability to make changes to the architecture in a way that other cloud database services don't. So our flexibility, our portability, it's second to none. All of the features of PPCD reside in the cluster manager console, not in the database, which means that our customers have the ability to move workloads to and from the cloud seamlessly, because the database is exactly the same for us, whether it's a physical instance, a virtualized database, or in the cloud. So, like many of our customers, you probably subdivide your workloads. Some of them are mission critical, and others aren't. You categorize them differently. We keep in mind that databases are a relatively horizontal solution. In other words, your particular industry vertical isn't as important as the actual workload. Now, Postgres is great for transactional workloads, as well as for web apps, for data stores, and as I mentioned, reporting. It's also a good fit for data warehousing, and we're constantly making improvements for using it with third-party software apps, too. Generally, however, we tend to focus on custom homegrown applications. Our customers are predominantly Java shops running Linux or Windows, but Postgres is also great for Perl, PHP, and Ruby developers, too. And keep in mind, most data warehouse vendors are also built on Postgres. Look at Greenplum or Vertica or Netezza, to name a few examples. So these categories in the fit matrix on the left side, OLTP, online transaction system, these are the systems that are capturing all your daily workload. Your web apps, same thing typically. ODS, which is your operational data store. That's helping to load your data warehouse environments. It's helping to support your analytical operational systems. Data warehouse data, enterprise data used to support business analysis and trending with cubes or star-based models, and typically aggregates, data marts, archiving. So why do we put data warehouses and ODS in the analysis required category down below? Well, these often rely heavily on cubes and stars and these other sorts of OLAP constructs. And Postgres doesn't really have broad support for a lot of those analytical functions today. And that's why we say, there'd be analysis required to see whether that would be a good fit. Anything there in the mission critical space it really should be placed in the analysis required category. Certain uptime requirements, certain write scalability requirements, I mean, if you're in extreme edge cases, some of those could be difficult to achieve with Postgres. But you wouldn't know unless you took the time to go through and have a look. So here, what you see is this is just a sample from some of our own customers. So these are customers who are using Postgres for a wide variety of workloads, and the capabilities of Postgres they continue to grow over time. I think that we're going to start to see more growth in this mission-critical application space here over time as companies get more and more familiar with using Postgres in these large enterprise deployments. So I would suggest that what has helped to drive the momentum to Postgres and why we've been successful in moving customers' workloads from higher cost proprietary database vendors to Postgres is the fact that there's a global enterprise vendor that has created a commercial database offering based on the open source project. So why is this important? Because here at EnterpriseDB, we have many community members working for the company, and we have thousands of customers using Postgres in enterprise environments. We start with community PostgreSQL, which is built by the contributors in the community. They decide what features they'd like to see, and they have the time to work on in the software. Then EnterpriseDB adds enterprise features based on customer needs, so including Oracle database compatibility. We add security features, we add performance enhancements, and then finally we add installers, we add testing, we build in add-on components, and all of this produces the end product of Postgres Plus Advanced Server, which is really easy to set up. The end result is a database that has all of the features and all of the fixes of PostgreSQL, plus the enterprise desired features for most users. But that's not really the end of the story. EnterpriseDB is a good open source citizen. We regularly contribute back to the community many of the features that we develop that they might find desirable as well. So it's a mutually beneficial relationship. And because of this collaboration with the open source project, the cost to deliver our products, while still significant, is exponentially lower than traditional proprietary database vendors, and we pass that cost savings on to our customers. So here in this case study slide, this is an example from one of our key IT partners, HP, and their outside consulting firm. Keep in mind, the lower cost of EDB even includes the services costs necessary to migrate the workload from Oracle to Postgres Plus Advanced Server. Pretty powerful stuff. Let's talk a little bit about enterprise enablement. So our enterprise enablement process will help you to navigate the waters from beginning to end. We've got great resources on best practices, we've got great pre-sales technical support, and we can help you to figure out optimal use cases. Plus, we have a variety of training and packaged service offerings that can provide you with the comfort you need to embark on this journey. From development into production and management, we continue to work with your team to ensure that you have optimal performance, reliability, and security. And lastly, I just want to say our enablement services are cyclical. So as you gain confidence, we help you expand the footprint throughout the organization, one step at a time. This is just a typical way that we would go through to help to assess the ease of migration. And it uses an Oracle schema. It's just one of our key service offerings is an Oracle migration assessment. It's a very easy, very thorough process to help you determine the best candidate workloads to move from Oracle to Postgres Plus. And this is just a brief survey. So you'll see here that half of our customers had slight or no modifications to make. We take migrations from man months or man years down to man weeks or days. And it's a reliable, safe, and cost-effective way to get there. Our customers actually agree in the soft cost savings. The reuse of their current skills is very important to them. This is something they don't get when they deploy a brand new solution that requires completely new training and a new skill set. Nobody wants to retool their entire shop. So the investments in that could be worthwhile, of course, but the returns can take far longer and there's much greater risk. So let me just take a minute to look at the differences between community PostgreSQL and our Postgres Plus Advanced Server. I described the fact that we add Oracle compatibility technology to the database to make it easy to migrate Oracle databases. We've included PL SQL syntax, plus most of the stored procedures that a developer would take advantage of when developing an application in Oracle. And as you've seen, this accelerates the migration process and it makes it safer, it makes it more cost-effective. We add features to this community Postgres database in 3 other categories: security, tools, and performance. And we ensure that the strong foundation that's built by the community has the enterprise-class features that companies expect when deploying databases in their production environment. And what's more, we do that at a cost that's 80 to 90% less expensive than Oracle. I couldn't not put this slide in here. As you can see here, we've actually caught the eye of the industry too. Notice that we're the only RDBMS in the challenger quadrant. We're the only company that the industry sees as a challenger to the traditional Big Four. So what Gartner learned after reviewing EnterpriseDB and speaking with dozens of our customers around the world is that we're providing the right products and services to ensure that our customers make the most out of their Postgres deployments. From our standard edition, which includes support for the open source PostgreSQL community version, to our enterprise edition, which includes our advanced server and our cloud database. We've definitely got the right database for your application. We back that all up with global follow-the-sun support, package services, and training, and also remote database administration services. So many of our customers are actually running a community version of Postgres, and they come to us for support and to take advantage of the additional functionality and the tools that we provide. For lots of workloads, this is a fine solution. The majority of our customers do run Postgres Plus, though. The combination of its low cost, along with a ton of additional features and functionality, makes it a great fit for workloads with lots of concurrent users and lots of transactions. And of course, our Postgres Plus Cloud database, which gives customers the ability to run either Postgres Community or Postgres Plus Advanced Server, but in a cloud environment. So we give our customers both the advantages of an open source project that is innovative and cost effective, and the benefit of a global enterprise software company that provides follow-the-sun support, services, and everything you'd expect from a commercial vendor. Actually, that wraps up my introduction. The intent is really to share some important information that many people need to know and want to hear about some ways to get started down the path to a lower cost alternative for managing their company's information workload. We're always available to answer any questions you may have about finding a sweet spot for open source databases in your own environment. And with that, I'd like to hand it off to our partner, SIOS. Tony has some great information to share with you about some easy ways to handle high availability solutions for Postgres, and he's dying to show you some useful examples. Thank you all, and have a great afternoon. Tony?
Excellent. Thanks, Brian, and hello, everyone. My name is Tony Tomarchio, and I'm with the field engineering team here at SIOS. And today, I'm going to be covering ways to ensure maximum uptime for your Postgres deployment, in a flexible, cost-effective way using our clustering software. But first, just briefly, I want to give you a bit of a background on SIOS Technologies. So SIOS Technologies has been around for well over a decade. We've been around since 1999, formerly known as Steeleye Technologies. We have a worldwide presence, and what we're going to be focusing on here today primarily is our SIOS Protection Suite software, which provides both high availability as well as real-time block-level data replication. So it gives you a lot of flexibility in the way that you choose to protect your mission-critical deployments of your Postgres database and other applications as well. So as I get into this, first of all, when you deploy a mission-critical database, if that goes down, there are going to be negative impacts to your business. That might be cost, could be lost revenues, lost productivity, or even things like lost customer satisfaction or reputation. So I have some examples here up on this slide that show, what an hour of downtime might cost, and this will certainly vary based on your type of business and your customers. But the bottom line is that the cost of downtime can be very expensive. And the cost of setting up a strategy and technology to ensure maximum uptime, setting up a cluster to fail over if there are issues or things of that nature, that is not a very costly thing. So you definitely want to get that in place and think about how you're going to address that as you make the deployment and deploy a mission-critical Postgres database here. So SIOS, we provide high availability software solutions, very flexible. We support both Linux and Windows deployments. You can really use any type of back-end storage configuration, whether that's a traditional cluster using shared storage, it could be fiber channel, iSCSI, network attached storage. But we also support what we'll refer to as SANless cluster configurations, where the different servers are perhaps using local storage. Could be traditional spinning hard drives, might be SSDs, things of that nature. In that case, you would have the ability to leverage our real-time data replication technology to keep the different systems synchronized. So if one fails, the other one comes online, and it's got a real-time copy of the data, so no data loss. You also have flexibility in where these systems are deployed. You could set up a cluster where all of the nodes are in a single data center, or you could set up a geo cluster where different systems are in different data centers, perhaps halfway around the world. You also have flexibility in how you deploy your systems. You could leverage physical servers, virtual servers, systems up in the cloud, or even a mix. So we don't dictate how you need to deploy your cluster configuration. It really comes down to the available servers and storage, along with your budget and business requirements, and we can come up with a solution that allow you to protect your environment. Also, very importantly, you want your clustering solution to be application aware. So not just, hey, is the process running? Is the database process there? But are things actually functioning properly? So our solutions actually look inside the protected application or database to make sure it's functioning properly. And we certainly support all the major Linux distributions, including Red Hat, SUSE, Oracle Linux, as well as even CentOS. So with our SIOS Protection Suite, on the right side of the screen, I've got a couple of sample diagrams. The one here up at the top is what I call a SANless cluster, where the two cluster nodes have independent storage. We handle the replication between them. Down at the bottom right, we have a more traditional SAN-based cluster, shared storage-based cluster, and that's what most people think of when I say the word cluster. Two or more servers connected to some type of shared storage. But that's not the only way to do this. You might not want to invest in a SAN. SANs represent cost, complexity, but also a potential single point of failure. If the shared storage goes down, it can take out your entire cluster. So, if you do have a SAN, you want to make use of that investment that you've already made, you can certainly form a cluster using that. If you want to deploy this in maybe virtual systems or up in the cloud where shared storage might not be available, or maybe you don't want to make the investment in that additional shared storage, we also give you options to leverage local storage using data replication. So a very flexible solution here. And when we detect an issue, we're going to try to recover that locally on the same machine before triggering a failover. So we do local recovery first, and then if that's unsuccessful, then we would fail over to another, basically a standby node in your cluster to bring the database back up to minimize the amount of downtime that your business will experience. So some of the key features here, you can deploy a number of different nodes. Most commonly, folks will deploy a two-node cluster. That's what I see the most out there in the ecosystem, but you can certainly deploy larger clusters based on your workload, based on your requirements, based on the hardware that you've got. The solution supports cascading and prioritized failover, so you can specify exactly which order you want databases to fail between systems in. We also support end-to-one and one-to-end failovers. So you might have one very large primary server running multiple database instances, and perhaps you don't have a server that's as big as a failover target. So maybe you do have 2 or 3 smaller systems, and maybe you fail the first database to node 2 and the next database to node 3 and the remaining databases to node 4. So you have a lot of flexibility in that regard. Again, from a storage perspective, really any type of backend storage can be used. So reuse existing servers and storage. It could be traditional, ways of doing this, like a fiber channel SAN, iSCSI SAN, NFS shared storage, or again, with our technology, you can leverage the real-time host-based replication. It's also very easy to monitor the status and to manage your highly available database. We provide a graphical user interface, which I'll show you a demonstration here in a few minutes, as well as command line interface as well. So you can choose the way you want to manage and monitor the state of your highly available database. We've also maintained a consistent architecture over time. So I mentioned we've been around for well over a decade. Between versions, we maintain a consistent architecture that allows you to perform rolling and in-place upgrades. So from going from one version of the cluster to another, you're not ripping and replacing. You can maintain your protection, maintain the configurations that you've set up, while at the same time going to new versions of the software and achieving the latest features and functions. A little bit more information. So our protection suite for Linux, we actually provide built-in knowledge for a lot of different Linux services and applications. Postgres is one that's supported right out of the box. But if you have other services that you need to protect along with this, maybe a custom application that sits on top of the database, you can really use this technology to protect the entire stack, from the application, the database, the network, the storage, the server, all of that. So it's looking at all layers of the stack. Not just the database. And that just increases your level of availability because solutions that only look at certain pieces of the system stack, your uptime is only as good as your weakest link. If you're not looking at the application, you're not looking at the networking, and you have an issue there, that can have additional side effects and trigger broader outages. So we provide comprehensive availability for the entire system stack here. So a little bit more information about the data replication technology that comes with our solution. So again, if you choose to go with what I call a SANless clustering architecture, also known as a shared nothing cluster architecture, basically where the different servers involved are not connected to the same shared storage, that's where our DataKeeper technology comes into play. DataKeeper, again, is real-time block-level data replication. So think of it as a software RAID 1 mirror going across the network. We support both synchronous and asynchronous replication, so it's suitable for both local area network as well as wide area network replication configurations. It also supports multi-target replication, so this does not have to be just a one-to-one. Maybe you want to have a 3-node or 4-node or more nodes in your cluster. Perhaps you want both local failover and remote failover. So you might put 2 or 3 nodes in one data center and a 3rd or 4th node in a secondary data center. So you have a lot of options in how you deploy the architecture to meet both your recovery time and your recovery point objectives here. Also, very conveniently, the data replication is fully integrated with failover. So if I've, let's say, got a 2-node cluster, node 1 and 2, and node 1 is active, data will be replicating from node 1 to node 2. Well, if node 1 fails and node 2 takes over, node 2 now becomes the new source of replication automatically, and data will start replicating in the opposite direction to get the original server back up to speed. So you don't have to worry about mirror management or mirror maintenance. It all gets handled automatically under the covers here. Also, because again we're doing block level replication, it's a very efficient way of replicating your data. Block level means we're not dealing with we don't have to look at locked files, open files, file permissions, things like that. The replication actually takes place beneath the file system, so that you've got a block for block replica of your disks. So again, think of it like a software RAID 1 mirror, but simply going across the network. This next slide here is a screenshot of our user interface. I'll show you a live demonstration in just a moment. But the highlight here is it's very easy to use. You can get an entire snapshot of your cluster deployment, see what's running where, what's online, what's offline, things like that. With a click of a button, you can move a database from one system to another, start and stop things, and it also provides very easy to use wizard-based setup so that you can get a brand new cluster set up in generally a matter of minutes. We're not talking days or weeks to deploy a cluster. We're talking minutes to hours typically here. And again, you can set up a traditional cluster using shared storage, but I just want to highlight again that if you're looking for a very low-cost, simple way to deploy things, I definitely recommend looking at SANless configurations. It eliminates the cost and complexity of managing, back-end shared storage. So not just the SAN, but the SAN, perhaps the networking infrastructure that goes along with the SAN administration, all of that. So with a SANless solution, you can just leverage the storage that lives inside the server itself. We'll replicate it. It's very simple, very cost-effective, very easy to set up here. So a quick case study here, and then we'll move into a live demonstration. So one of our customers, that's a joint customer here of both of ours, they're a software as a service provider, and they have a web platform that handles reservation services for airlines, hotels, and so on. And they were deploying Postgres database, actually had multiple different databases that were all mission critical supporting this customer-facing website. And it's processing thousands and thousands of transactions per day. And what they decided to do is they actually deployed an 8-node cluster. They had 7 different databases running on 7 different servers, and they had 1 standby node. So again, this was a configuration that met their specific requirements, again, very flexible in the number of nodes you can deploy. So they ended up going with an 8-node cluster with shared storage, multi-path fiber channel SAN as the back end, because they already had that type of a storage infrastructure. So that was a sweet spot for a solution as well. And they needed an affordable, easy-to-use way to accomplish this. They had these servers already. They had the storage. They just were missing the piece on how can I make this highly available. So some of the results they were able to achieve by deploying the solution here, first of all, ease of installation. They were had the cluster fully set up, and their databases were protected within less than a day. They've been a customer for a number of years. Over the past couple of years, they've had over 99.95% uptime. And, actually they had a scenario where one of their 7 database servers was essentially like the master database server that other ones depended upon. That one was mislabeled, and it was powered off incorrectly. And the clustering software failed it over to the standby node seamlessly. Nobody even noticed. There was not a blip. It just brought it back online, and life as they knew it was continuing here. So with that, let me spend just a couple of minutes giving you a brief demonstration. I'll show you what the software looks like and how we can very easily protect a database and make it highly available here. So with that, I'm going to share out my desktop, and we'll take a look at my environment here. So here, I've got a couple of systems, and let me connect into them here really quick. Okay, so here I've connected into a Linux cluster here, and my servers are called PGSQL1 and PGSQL2, and it's a simple 2-node cluster, but this is a SANless configuration, so there's no shared storage involved. I've got 2 servers. They each have their own local storage, and our solution is replicating the storage where all of my databases live in real time. So again, think software RAID 1 mirror across the network. So if we look, I've got this cluster partially set up, and we're going to finish the setup here in just a moment or two. But I can see here at the top that I've got my 2 cluster nodes. The green check marks indicate that everything is healthy and everything is online. So I've got multiple heartbeat paths going between, so I've got redundant network connections here. Then if we look on the left, I can see the resources that are currently being protected. So I've got this virtual IP address, so think of this like a floating IP, and this is how your applications or your users get redirected when you fail over between different cluster nodes. So this IP, for example, that ends in .38, it will move and it will be active on the active cluster node. So any application connecting to this virtual IP will automatically find its way to the active node in the cluster. So this makes client redirection very seamless here. Also, all of my databases live here. I've left this as the default location, so under var lib PGSQL. And underneath that, I've got this data rep resource, which stands for data replication, where right now, server 1 is the source and server 2 is the target. If I bring up a command prompt and we take a look at my disk layout, you don't notice anything special here. I've got this var lib PGSQL file system. but you'll notice that it's mounted here as devmd0. So it looks just like a traditional software RAID, as if I took a server, put in 2 hard drives, and used the MD80M utilities to create a software RAID. That's basically what we've got here. If I dig a little bit deeper and we look at procmdstat here, I can see that the mirror is actually comprised of SDB1, which is my local disk inside this machine, and the second leg of the mirror is NBD. This is a network block device, and that's how we transmit the second copy of the data over to the target server. So when writes come down, any data gets written to this file system, could be any of the databases in there. They all, the data gets replicated, and all of your data gets protected in real time. So that kind of shows kind of the background here. I've got the protected file system. I've got a protected IP address, and we'll spend a minute or two now. I'm going to protect the Postgres database here. So I'm going to create a new resource and go through a simple wizard, tell it what type of a resource I want to protect, and go through and click Next a couple of times. The switchback determines what happens when the failed node restores. Do you bring it back to the original node, or do you leave it where it is? It's asking me what my primary server is, which is server 1, where the executables live. And I have everything in the default location right now, but you can certainly adjust this as needed. It does detect this for you automatically. So here's the client executable. So the nice thing about this is you can pretty much click Next, Next, Next. Here it's asking me where the pgctl command lives, and it automatically detected where my data directory was, and click Next. The port that the database is running on, and so on. So here, so it's just asking for my database user here. And we'll just go through this really quick. And right now it's creating that. So I went through a simple wizard. It asked me basically one question, which is what user do I want to use to connect into the database with, so we can monitor its status. And it's setting this all up for me. You'll notice that the file system resource looks like it disappeared. It really didn't. We just simply put it underneath the database because we know that the database depends on data in that location. So we've created a dependency for you automatically. We want to make sure that the file system and the disk fail over along with the database, so everything moves as a group. So that's all done. So we've just successfully created a cluster resource for the database on the primary node. And next, what we do is called extending the resource, where essentially we're defining the backup node, so which server will take over in the event of a failure. And it selected node 2 here for me. And what it's doing is it's updating node 2's configuration automatically so that node 2 knows how and when to take over in case of a failure here. So this will take just a moment or two, and once that's done, what we'll do is I'll actually show you how you can create custom dependencies. I'm going to create a dependency so that the IP address, the virtual IP in the cluster, moves with the database as well. You want basically everything to move as a group. And then once that's done, I'll trigger a failover. We'll fail over the database from node 1 to node 2. That takes just a few moments, and it brings everything back online on the standby node. So you can see here it's updating the user interface. It's defining everything on the secondary node, and that's just completed here. So now I've got a setup where I've got a database that's both active and it's protected. So it's online and it's highly available. So if my node 1 fails, if it can't be restarted locally, it'll fail over to node 2. So I'm going to simply click Finish. Now I'm going to create a dependency, so I want the IP to move with the database, so I simply right-click and say Create Dependency. And we'll tell it that we want the IP to move. And it'll put the IP underneath the database as a group. The final thing I'm going to show you in the demonstration before we wrap things up and open things up for to see if there's any additional questions is let's fail this over really quick. So if somebody goes and kicks the power cord, that would trigger a failover. But let's say I want to take down node 1 to do some hardware maintenance, or I want to do some OS patching, things like that. I want to move this away from that node before I take it down. So I'm simply going to right-click under node 2 and say In Service. And what this is going to do is it's going to cleanly shut everything down on node 1 and then bring it back online on node 2. So a planned failover actually takes a little bit longer than an unplanned, because here we're cleaning things up. We're stopping things cleanly. We're unmounting the file system. We're recreating stopping the mirror, and then we're going to recreate in the opposite direction, moving the IP. If this was a hard failure, somebody kicked the power cord out, let's say, there's nothing to clean up. There's nothing to shut down. The remaining node would automatically detect that the active node is gone, and it'll fail everything over. So right now it's switched over the mirror, so now data is replicating from node 2 back to node 1. It's moving over the IP. It's mounted the file system, and then it's going to start up the database. So with the click of a button, I've done a cluster failover, moved my entire resource hierarchy, so the database, the storage, and the IP address from node 1 over to node 2. So that's a brief demonstration on how easy it is to both set up and manage a highly available Postgres database using the SIOS Protection Suite for Linux here. What I'm going to do here, we'll just wrap things up. Just to kind of recap, you've got a lot of flexibility. It's all about clusters your way. You can set up, using different types of servers, different types of storage, single site, multi-site, cloud, virtual, physical. It all supported here. So again, very easy to set up, very easy. With SANless cluster, you've got a smaller footprint. You've got just the servers involved. You don't have to worry about extra data center space for that SAN necessarily if that's not something you want to invest in here. So with that, I think if you want more information, we've got some contact information here up on the screen. And I think with that, we'll open it up and see what questions came in via the Q&A panel that we haven't yet addressed.
Yep. Tony, can you hear me?
Yes, I sure can.
Okay, great. We have a couple questions for you. Does SIOS Protection Suite require special scripting to deploy and configure?
Okay, excellent question. The short answer is no. So you saw in the demonstration today that we provide those simple wizards that go through and allow you to set up the cluster. So you don't have to write any scripts in order to get this done, so very easy to use. And we have we call them application recovery kits, or ARKs, A-R-K. These are the predefined cluster agents, if you will, that know how to protect various databases and services and applications. Now, that said, if you have some custom application that you want to protect on top of, let's say, the Postgres database, you do have the flexibility to write some custom scripts and do that, but that's not required. So it's only if you want to protect custom services or applications here. But for everything that we've got a recovery kit for, no scripting required whatsoever.
Okay, another question for you. If I have other services or applications in addition to the database, can those be protected too?
Yes, yeah, so excellent question. Yeah, you're definitely not limited to just protecting the database. So, out of the box, we can protect, various databases, networking, storage configurations, data replication, and so on. But if you have a custom application that you've written, or a third-party application that you want to, that sits in front of the Postgres database, you can certainly protect that as well. We have what we call our generic application recovery kit, which is where you can define the stop, start, and monitor procedures to bring that service or application under protection of the cluster as well. It's a great question.
Great, great. I have a couple of a couple of questions from one attendee for Brian Berryman. For non-Oracle, such as Sybase or MySQL, do I need Postgres Plus or PostgreSQL? I mean, my impression is that the Plus is more for Oracle compatibility. Or which one, Postgres Plus, Advanced Server, or PostgreSQL, can do master replication among multi-data centers? Sorry about that, Brian.
Okay, so there's actually two questions there. So I think if you're coming from a Sybase or a SQL Server world, there's no compelling, you could certainly go to Community Postgres or to Postgres Plus Advanced Server. For those folks who happen to be on Oracle, there's an even easier path to get to a Postgres world. The Postgres Plus Advanced Server has an Oracle compatibility layer that enables you to take and lift all your store procedure and stored code and drop it into an Oracle, into the Oracle compatibility layer in Postgres Plus Advanced Server, and you can run it there. Many customers find that there are very few modifications required to do that. Some find that no modifications are required. So if it's a quick path that you're looking for to be able to test drive and kick the tires of a migration to a Postgres world from an Oracle database, Postgres Plus Advanced Server can do that, but the community version cannot. With regards to your multi-master replication question, so we have a tool with that's included in the subscription to Postgres Plus Advanced Server, what we call our Enterprise Edition subscription. It's called XDB Replication Server, and the multi-master version of that is only available in the Enterprise Edition for free. It's available in the community version, the standard supports additions, subscription as well, but at an incremental cost.
Okay, great. I think we're almost out of time here. So I want to say thank you to Brian and Tony. It was a great presentation. You've addressed the key points of the market and how organizations can save money with Postgres and leverage SIOS for high availability. This webinar was recorded, and the recording and the slides will be sent to all the attendees in the next few days. Have a great day.
Oh, thanks.